Hi. So basically, you already said what a plugin generator is. It's a tool to generate audio plugins or standalones using a visual programming paradigm. At the moment, we only use pure data, but it's only because we were used to use it. Why did we develop this technology? Well, at AudioGaming, we have two ways of creating new plugins. The first one, which you see schematized here, starts with a DSP expert developing a prototype, usually in Python. And after lots of iterations, when we are sure of what the features will be, the designer develops the user interface, then the developers re-implement the prototype in C++. They integrate the user interface, and after some optimization, testing, and debugs, the plugin is done. So the second process we have is basically the same, except the prototyping phase is not done by a DSP expert. It's done by a sound designer, and it's not done in Python, but with pure data. So we thought in both cases that the development phase was really too long, and it really felt like a loss of time to re-implement something that we had already done in another language. So we thought, why can't we bypass this step of the process? And we tried to imagine a new way, a new process of creating plugins, which would be the same at the beginning. There's still the sound designer making the pure data patch, the graphic designer making the user interface. But instead of having developers re-implementing everything, we would have this technology that would take the prototype, take the user interface, and generate a final product. So obviously, for it to work, we had to add a little task for the graphic designer, that he has to write a little description file for the user interface to allow plugin generator to generate a nice user interface and not something completely random. So as you can see, it's just a simple XML file. It's really easy to write. You don't need to be a developer to do it. It just says where the buttons are on the user interface, which image to use, what are the dimensions, things like that. So when we started this project, we looked at some existing technologies, like libpd, which is a wrapper around the pure data source code. So the good thing about that is that a patch processed by pure data or a patch processed by libpd does exactly the same sound, which is exactly what we wanted, of course. But there is another problem with that, and this problem is that because it uses pure data source code, it has exactly the same problems as pure data. And one of these problems is that it cannot be used in a multi-threaded environment. But it can be used in a multi-threaded environment, but you cannot run multiple instances of a plugin using libpd at the same time, which make libpd useless for developing plugins. And on top of that, I don't know if anyone of you has ever tried to read the pure data source code, but it's like a very old C code. It's really hard to read. You have like 10,000 global variables that are all named _s, __s, and you have to understand what it does. So it was too complicated for us to try to fix it, to make it work in a multi-threaded environment, so we decided not to use libpd. We looked at other technologies like Garden, which is an open source library you can find on GitHub, which does the same thing as libpd, but is not using pure data source code. It's a new code base with modern coding. It's in C++. It's like really easy to understand and to modify if you want. And also it supports multi-thread. So it looked like the right choice to use it. So we developed a prototype with it, which was working so-so. But we noticed that there was a lot of differences between the sound of the patch processed by pure data and the sound of the patch processed by Garden. Lots of different behaviors of pure data, specific behaviors were not supported by Garden 2. And also we found several little bugs here and there, and the architecture was not really what we wanted. So we also decided that Zen was not what we wanted to use. It would take too much time to make it work for us. So we decided that maybe it was a better idea to develop our own audio engine that would process the patches. So here you have a little scheme of how a plugin generated with plugin generator works. So we use Juice, as he said, to be able to export in all different plugin standards like VST, AAX, audio units, and to interface with the DAW. We have a little module in the plugin that will parse the patch and rebuild it in a way that is understandable by our engine. What I mean is that the patch will not be interpreted like in an interpreted language. There is this phase with this module which rebuilds like a graph of objects that will be processed by the audio engine. We also have this module that parses the UI description file that I'll show you earlier and generates a user interface using also the Juice UI system, and which is automatically linked to the real-time audio engine to be able to control the parameters we want the user to be able to control. We also have lots of little options you can add to your plugins. When you generate them, you can add a preset system, OSC support, iLock licensing, and a lot of other options that I'm not going to enumerate. But now I'm going to show you a little bit what it can do. Okay, yes. Hello. So here we have pure data patch we designed. So I'm not going to go over what it does, but it has several modules. Can make different type of sounds. Like we have this module, which you can play with the parameter if you want. But it just does like some kind of. The idea was to make some submarine-like sound. And maybe we can add some sonar sound on it. I don't know. Get some random values. I don't know. Okay, just so you can see the sounds it can make. So I'm not going to generate the plugin in front of you because it takes several minutes, but here is the final result, the generated plugin. So I'm going to show you here. It makes the same sounds approximately. I don't know which parameters, which value as I choose for the parameters before, but I'm going to try to make something close. I think it was something like that, maybe. Those parameters. Okay. Something like that. So it's as easy as that. You just have to make your pure data patch, write your little XML file to describe the user interface. Of course, if you want to have a nice user interface, you also need to have a graphic designer to do the pictures, of course. But it will generate the final product in VST, AAX, or audio units for Mac or Windows, 32 or 62 bytes, whatever you want. Like as you can see, you also have the preset system, which the little option I talked about, we added here. But of course, the presets itself are not generated. You have to write them in an XML file too. But the whole system is here. You can, like the user can save presets if you want. Here's this new preset. Standard stuff. Okay. Let's go back to the presentation. Yes. So now, how about the future of this technology? We are planning to add new features. We would like to be able to export maybe Fmod and Wise plugins. Also thinking about new targets, new platforms to export for, like ARM, DSP. We're also thinking about gaming consoles. Well, at the moment, it's not possible because performances are not good enough. But there is lots of room for optimization in the technology, so we have hopes that in the future it will be possible. And we are also thinking about new type of inputs that plugin generator could take to generate those plugins, like compiled libraries, for example, which is something we are already working on and is almost done. Maybe Python script, I don't know. So we can use plugin generator for both our processes of development. But at the moment, this technology is only an internal tool at AudioGaming. But we think that if we had this need, there is a chance that other people need it too. So we'd like to find a way to spread the technology, but we are not really sure what is the best way to do it and what the people that are interested in such a technology want. We thought of different ways, like maybe just a simple service, maybe an online platform where people could freely generate their plugins and share it on some kind of store or sell it. I don't know. We also thought of the idea of developing like some big integrated development environment for audio plugins specifically, which would be non-developer friendly, because the big advantage of this technology is that you don't need to be a developer to create a plugin. Well, you could, this kind of software where you could design the user interface, you could design the processing part of your plugin, a bit like something like pure data, and you could generate the plugin with just the click of a button and some minutes of patience, of course. So this presentation, yes, at the end of this presentation, it was short because I wanted to start a discussion. If there is people interested in this technology, we are really interested in what they think and what they want to do with it and how they would like to use it. So I don't know if it's going to be possible, if maybe there is no people interested in this technology, I don't know. But maybe the best way to do it is before to answer questions if you have any, and maybe we can talk about it after. Also, if you don't have time to come to talk to me, you can also write me an email that you have. So that's it. Thanks for listening.